Let us journey into the deepest layers of reality, to a realm so small that it defies imagination, a world where the very essence of matter is revealed in its most fundamental form. Here, atoms are no longer the smallest units, they are mere containers for even tinier entities, protons and neutrons, and within them, an even stranger, more mysterious world exists. This is the world of quarks. Quarks are not visible, not in the ordinary sense, and they cannot exist alone. They are always confined, forever bound by an invisible yet incredibly powerful force, a force so strong that no human tool can pull them apart. The strong nuclear force, mediated by particles called gluons, keeps quarks locked in a perpetual embrace, creating the protons and neutrons that, in turn, build every atom in the universe, including the very atoms in your body. Each quark is unique, carrying properties that sound almost whimsical but are absolutely fundamental: flavor, color charge, and spin. The flavors, up, down, strange, charm, bottom, and top, define how quarks behave, how they combine, and what kind of particle they create. The up and down quarks dominate ordinary matter, they are the quarks that make up the protons and neutrons in atomic nuclei. But the other flavors, the strange, charm, bottom, and top quarks, appear in exotic particles produced in high-energy collisions, giving us glimpses into extreme, almost alien realms of physics that existed in the early universe and still exist in cosmic rays that constantly bombard Earth. Color charge, not a literal color, is a property that quarks possess, dictating the rules of their interactions under quantum chromodynamics, or QCD. It is as if each quark carries a secret identity, a hidden color that must combine perfectly with others to form a neutral, observable particle. A proton, for instance, contains two up quarks and one down quark, each with a different color charge, their interactions mediated by gluons. Gluons themselves carry color, allowing them to interact with each other as well as the quarks, creating a complex, dynamic dance of energy and force that gives the proton its mass and stability. The energy of these interactions is immense, in fact. Most of a proton's mass comes not from the quarks themselves, which are almost massless in comparison, but from the energy of their motion and the gluon interactions binding them together. Here, Einstein's famous equation E equals mc squared becomes vividly real. Energy itself creates mass, quarks are never at rest. Within a proton, they whirl and oscillate, exchanging gluons in an almost chaotic, yet perfectly orchestrated, quantum ballet. This internal activity is invisible to the naked eye, yet it is the engine of the physical universe. Without this constant interplay, atoms could not exist, molecules could not form, and life as we know it would be impossible. It is humbling to consider that everything around us, every stone, every leaf, every breath we take, is built on these invisible dances, on interactions that we can only perceive through mathematical equations and particle accelerator experiments. The strange behaviors of quarks also reveal the universe's subtle asymmetries and peculiarities. Certain combinations of quarks form particles that decay in ways that violate our expectations of symmetry, hinting at deeper truths about why matter exists in the universe while antimatter seems almost absent. Studying quarks is not merely an academic exercise, it is a probe into the origins of existence itself, an attempt to understand why there is something rather than nothing. High-energy experiments, such as those conducted at the Large Hadron Collider, allow scientists to glimpse quarks in extreme conditions. When protons collide at near-light speeds, quarks are temporarily freed in the form of jets of particles, giving us fleeting evidence of the inner world we cannot otherwise observe. These experiments confirm predictions of the Standard Model, yet also raise new questions. Why are there 6 flavors of quarks? Why does the top quark weigh so much more than the others? And what hidden laws of nature govern their interactions in ways we have yet to discover? In the realm of quarks, classical intuition fails. Space and time become fuzzy, probabilities replace certainties, and the very act of observation can alter outcomes. Quarks exist in superpositions, vibrating between possibilities until a measurement collapses them into reality. This is a world where the familiar notions of cause and effect are supplanted by subtle, probabilistic rules, where the tiniest fluctuations can have profound consequences, and where the boundaries between matter and energy blur. Yet even in this hidden world, there is beauty and order. The mathematical symmetries governing quark interactions are elegant and precise, forming patterns that physicists can describe with exquisite equations, but patterns that also hint at a reality far stranger and more wondrous than anything we encounter in daily life. The quarks, through their ceaseless motion and interactions, construct the universe from the ground up, forming the nuclei of atoms, the elements of the periodic table, the stars in the sky, and ultimately the living world that contemplates them. To explore quarks is to confront the limits of perception, to peer behind the curtain of reality itself. It is to understand that the solidity of matter is an illusion, a product of countless invisible interactions occurring at scales we cannot see. The world of quarks is not just a microscopic curiosity, it is the foundation of existence, the engine of mass, and the hidden symphony upon which the universe is built. In this realm, the familiar gives way to the extraordinary, the tangible is replaced by the abstract. And the very notion of what is real is challenged. As we conclude our journey into this hidden world, remember that quarks are everywhere, within every atom of every object around us. They are the silent architects of reality, the ultimate building blocks, performing a perpetual dance that sustains the universe. The study of quarks is not just physics, it is a glimpse into the poetry of the cosmos, a reminder that the universe is far deeper, stranger, and more interconnected than our senses alone can reveal. To know quarks is to touch the foundation of all matter, to understand the forces that shape existence, and to glimpse the elegant yet mysterious logic upon which reality rests.